Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the questions of GATE 1992 and we have completed the 1990 and 1991. So uh, in 1992 specifically, we started with the section B. So today we have a new question. So without wasting time, we will go into the question. So what question is saying? Water is forced into the device shown in figure below at a rate of 0.15 meter cube per second through pipe A. So through pipe A, water is flowing and oil of specific gravity 0.8 forced at a rate of 0.05 meter cube through pipe B. So through pipe B, we have an oil of specific gravity 800. If the liquid are incompressible and form a homogeneous mixture of oil globules in water, what is the average velocity and density of mixture leaving through pipe C, having a diameter of 7 by 22 meter? Okay. So we have to find the average velocity through pipe C and density through pipe density of the mixture. So total volumetric flow rate in pipe C will be the sum of the volumetric flow rate of pipe A and volumetric flow rate of pipe B, right? So it will give the value of 0.2 meter cube per second. Now we have to find the average velocity. So we know that for average velocity there is a single formula, Q is equal to area of cross sectional and average velocity. So this is the formula. So we have Q 0.2 meter cube per second and area is the pi d square by 4 into V average. So we have applied this formula on pipe C. So the diameter of pipe C is 7 by 22 meter. So putting all the values and it will give the value V average as 2.51 meter per second, 2.51 meter per second. Okay. So the second thing, density of the mixture. So density of the resultant mixture will be given by average mass flow rate divided by the volumetric flow rate. So average mass flow rate will be in kg per second and total volumetric flow rate will be in meter cube per second. So second and second will cancel out and it will give the dimension of density. So putting all the values, so average mass flow rate, we know that mass flow rate is the density into volumetric flow rate. So density of water is 1000 kg per meter cube into 0.15 meter cube per second is the volumetric flow rate through pipe A. That is the water is flowing through pipe A. Similarly, 800 kg per meter cube into 0.05 meter cube per second. So second will cancel out. Okay. So it will give 950 kg per meter cube. So hope you understand this question. If you have any doubt, just comment it below. I will reply as soon as possible. Okay, let's go to the next question. So particles of average feed size 25 into 10 power minus 4 meter are crushed to an average product size of 5 into 10 power minus 4 meter at a rate of 15 tons per hour. At this rate, the crusher consumes 32 kilowatt of power, of which 2 kilowatt are required for running the mill empty. What will be the power consumption if 40 tons per hour of this product is further crushed to 1 into 10 power minus 4 meter size in the same mill? Assume Rittinger's law is applicable. So very first thing in this questions we should know that what is Kick's law, what is Bond's law, and what is Rittinger's law. Okay. So we have to calculate the power consumption required for the particle size 10 to the minus 4. Okay, so we have to reduce the particle up to the diameter of 10 to the minus 4. So we know that the universal equation of crushing. This is the universal equation of crushing. Okay, this is the universal equation of crushing. For Kick's law, n is equal to 1. For Rittinger's law, n is equal to 2. And for Bond's law, n is equal to all the values and integrate this equation from df to dp. Putting all these values and integrating. So for n equal to 1, we will get this, where C will be replaced by Kick's constant. Similarly, when we put n is equal to 2, it will give Rittinger's law, and C is replaced by Kr. That is it. This is Kick's constant, this is Rittinger's constant. And similarly for Bond's law, n is equal to 3 by 2, and it will give this formula where C is equal to 0.3162 work index, right? So applying Rittinger's law, this is Rittinger's law, and putting all the values. So 32 minus 2, because the 2 kilowatt of energy is required for running the mill empty. So we have to subtract that because it will not contribute for the crushing of the product. So 32 minus 2 will be the energy required for crushing, right? It will completely contribute it for crushing the feed to desired product. Now solving, it will give Kr equal to 0.00125. Now the question is saying from the same feed, from the further 5 into 10 to the power minus 4, it is reducing to 10 to the power minus 4. So it will again, we have to calculate the power. So this time we have Kr. So now we have calculated Rittinger's constant, and this time we have to calculate the power for reducing the product size up to till 10 to the power minus 4, from 5 into 10 to the power minus 4. So putting all the values in the Rittinger's law again and calculating power, so it will give power equal to 400 kilowatt. Okay, so this is very straightforward question, and I don't think so that there is some difficulty in understanding this question. But somehow if you are not able to understand, just comment it below.